Okay, you're with me? You're with me. All right. So here we are. Now, I've made this kind of big. Because I was going to do a different type of problem or a different problem, but this one's pretty straightforward because they already give us what V is. It's 25 meters per second. All right. So this one's going up here 25 meters per second. This is going this way 25 meters. So we know that there's a final velocity in the y direction of that, and then this one, and I. And I really believe that's where we're going to find our answers here. So they want V final F. Write an expression for the speed of the larger piece that is in terms of only the variable V. Okay, because the m's are going to cancel out. To me, we'll do that last. Let's figure out what the numeric value for V is. Let's figure out what that numeric value for V is in terms of these two V's. Okay, and we've got it in terms of the variable V. All right, so we have, in other words, they want us to come up with. We got this. I'm sorry, I keep kind of going. Well, let's go ahead and do it. Let's go ahead and do that first because there's really nothing to this. All right, there's really nothing to this, and let's this. Woo, that's big and ugly. So let's make this a little bit smaller, and just go ahead and get this done. Somewhat. And so here we go. So the V here is 25 meters per second. All right, V is 25 meters. And we know that, I'm just going to work it out down here, that the momentum before in the x direction is going to equal the momentum after. I'm getting kind of lazy here, forgetting to put the things there. All right, so the momentum before is 0 in the x direction. The momentum after in the x direction is little m times V. Okay. And minus, look at this, minus 3m times, now, this is the angle that we're using. Since this is, see what they did to us? They've got the angle measured this way off theta, which is fine. We can do that. Here's theta, here's V final going this way. Here's V final going this way. But since theta's there, then the x component is here, and the y component is here, so the y component is the cosine theta, and this one's the sine theta. All right, so this is VF cosine theta, and this is VF sine theta. All right, for the x direction. So we've got 0 is equal to mv minus 3m v final times the sine of theta. This problem isn't that hard. Okay. If they don't tell me what the heck, hold on a second. I'm about to get too heated here. Here we go. We can see this now. Do you see on here anywhere where they give me the value of V? Or the value of that angle? Dun, dun, dun. Well, these, okay. All right. Maybe we'll have to figure that out. Oh yeah, we can figure that out. We don't need to put that sign in there. I'm sorry. I've got about a million things because I'm trying to get out of here for spring break too, just like you all are. Okay. So VFX. All right. VF minus VFX because it's going that way. All right. So MV. So MV then is equal to, let's add this 3m V final X. Okay. So V final of X, so big V final of x, v final of x is equal to, notice the m's cancel, is equal to v over 3. And they gave us v. Okay? All right? And then, oh my goodness. Now let's look at the sum of the, in the y direction, is equal to this in the y direction. All right? And I wonder, I bet the same darn thing's going to happen here. Look what happens. That's going to be a 45 degree. It's symmetry. You always look at a problem and go, hey, where's my, is this symmetrical? Hell yeah, look at that. You got this going this way, this going that way, that coming down here. It's going to have to be, because I bet you Vyx, look. This is going to be 0, because before it blew up, the momentum in the y direction was 0. All right. After it blew up, we've got m times v minus 3m v final y. Well, look at v final y when we solve for it. V final y is equal to, again, the m's all cancel out, and v final y is equal to v over 3. Well, those two guys are equal to each other. So I know this. I know that v final, without using any is equal to the square root of v over 3 squared plus v over 3 squared. Remember, all of it's squared. And then take the square root of it. So we're going to wind up v final then is equal to the square root of 2. Is the square root of 2 times v over 3 squared, right? So I've got it's v over 3 times square root of 2. I wonder if I can write that expression that way. I wonder if they'll let me do that. V final equals square root, they got a square root sign here, square root of 2 times v over 3. So that's right. Submit. We rock. All right, so you guys can do that. I like it that they let me do that, and they're saying, oh, no, it's this one. Whatever. So now all you got to do is plug in, put 25 in there for V. See, so you just take 25 divided by 3. Square root of 2. I wonder if they'll let me do this. Yeah. And the angle, since it's got symmetry, is 45 degrees. Boy, they made that seem hard. That thing was not hard. Yeah. All right. The big takeaway, I'm sorry I started having fun with that, but the big takeaway from this is that you look at the symmetry of the problem. One thing was when you get good at this, you look at the symmetry of the problem. But the big thing I want you to see is the momentum before was equal to 0. Okay. And then the momentum, and so that helped us solve that. And then because the masses were in terms of each other, we could cancel out that m variable. Piece of cake. That was much easier than what I was going to do for you out of the other book. All right. That's actually kind of fun. If you like All Night Dennis. No. All right. Out here.